In this lesson we're going to look at how to pass the final outcome of the unit to NAB higher, outcome 4. In this outcome you require 10 out of 14 to pass. So question 9, a circle has radius 7 units and centre point 2, -3. Write down the equation of the circle. So we go to our formula sheet, and on your formula sheet you will see this, where AB is the centre point. So 2 can just be substituted in as A, and -3 is B, which means this is going to end up with a plus, and 7 can go in here. For your marks, the first mark is for getting the brackets correct, and the second mark is for finally squaring out the 7 to get 49. So an easy 2 marks here. Part B, a circle has equation x squared plus y squared minus 10x plus 6y take away 3 equals 0. This is the expanded form. We have to write down the radius and the coordinates of the centre. Go to your formula sheet and look for the expanded formula of a circle. It tells you what the centre is and also a formula to get the radius. So to get the centre point, 2g relates to the coefficient of x, which is -10, and 2f relates to the coefficient of y, which is 6. Half them, and then the centre point is -g, -f, so that's going to be a 5 and -3. So 5, -3 for your first mark here. To get the radius, we need to use this formula, g squared plus f squared minus c, the square root. C is -3 from up here. So sub those values in, -5 squared plus 3 squared, and it's take away -3. Some people miss that, they write just take away 3, but it's subtract -3 here, and you'll get a mark for doing that. Finally, if we multiply this out and square root it for our final mark. So we've got 25 plus 9 and then add 3. And that comes to root 37. You can leave it like that. Question 10. Show that the straight line y equals -2x take away 3 is a tangent to the circle with equation and so on here. So we have to substitute this -2x take away 3 into the circle equation. So wherever you see a y, put -2x minus 3. Remember to put it in brackets. That's going to look like this for a mark. So you've put that in here, and then you've put it in just before the 4. So this relies on you being good with your algebra. We have to simplify this down and then solve it. Now my advice would be to write this double bracket out. So -2x take away 3 times -2x take away 3. I'm just going to do it here without doing that, but if you're in the test situation or the NAB situation, then do that. But -2x squared is going to give you 4x squared, and then you're going to have -2x times -3, that's going to give you a plus 6, and then you're going to do that again, you're going to have another plus 6, which is going to give you plus 12, and -3 times -3 is plus 9. Multiplying that bracket out. You've then got a plus 6x, then we'll get 4 times -2x, which is -8, and then 4 times -3, which is -12, and then a plus 8. So collecting the terms up here, we've got 5x squared, so that's our first term. The x's, you've got 12 plus 6, take away 8, which makes 10. And then the numbers, you've got 9 add 8 if you like, which is 17, take away 12, which is 5. We'll get a mark for doing that. To solve this, we want to factorise it. So we'll take a common factor of 5 out first. You're going to have x squared plus 2x plus 1 here. And this will go into double brackets of x plus 1 times x plus 1. You'll get a mark for that. Now, because x is going to equal -1 or -1, then we can write a statement to say why it's a tangent. The whole idea was we were to show that the straight line is a tangent to the circle. So because the solutions are equal, there's only one point of contact. Therefore the line's a tangent. You need to write that sentence for your final mark there. Now, there's an alternative way to do this. At this point, you could use a discriminant. A is 5, and B is 10, and C is 5. And if you prove that b squared minus 40c comes to 0, that means there's only one point of contact. There's only one root, and you can write a statement to do that. That would be absolutely fine, and you get full marks for that.